In this video, we're going to talk about how to simplify cube roots and other roots. I just did a video, posted a video about square roots. So if you're new to simplifying roots, then I would recommend checking that out. This is going to be talking about cube roots and above. So remember that when we see a root symbol without anything here in this space, then it is an assumed 2, right? So that means that 2 of the same numbers multiplied together would give us whatever that number is inside that square root symbol. So with cube roots, when we see the little 3 right here outside of the root symbol, that means that we need 3 of the same thing multiplied together to give us whatever that number is inside. Same with fourth root. Whenever we have a 4 outside, we would need 4 of the same thing, and so on and so forth for the same for the fifth root, sixth root, and on. So let's take a look at a couple of these problems, and I encourage you to pause the video, try some of these out on your own, and then resume and see if you got them right. So we see a 3 here, meaning that this is a cube root of 8. So we're trying to figure out what number 3 of those numbers times themselves would give us 8. So one way that we can figure this out is by using a factor tree. And what that means is we're going to take this 8 and factor it out, find out its prime factors, and then if we have 3 of the same factor, then that's going to be our simplified root. So for 8, we can factor into 2 times 4. 2 is a prime number, so I'm going to go ahead and circle that 2. That kind of stops that branch of my factor tree. But with 4, we can continue going, and that factors into 2 times 2. Those are all prime. So let's look at what we have. We've gotten down to all of our prime numbers. We do have 3 2's, so then that means that the cube root of 8 gives us just 2. So notice here how even though we have 3 2's as our factors of 8, that is going to equal just a single 2 as our answer. Because remember, we want to answer the question, what times itself, what 3 of them times themselves would equal 8? Well, that would have to be 2 times 2 times 2. So when we are finding the cube root, the simplified cube root of a number of a perfect cube, in this case, this is a perfect cube, then we wind up with just 2 as our whole number. Let's try it with the cube root of 216. So again, we're going to start by using our factor tree. I know that 2 can go into this number evenly because it's an even number. So that is can go into 2 1 time, can go into 1 0 times, can go into 16 8 times. All right, so with 108, we can keep going with that. I know that 2 can go into that number as well. So 2 can go into 10 5 times, and 2 can go into 8 4 times. 2 is a prime number, so I'm just going to circle that prime number there. With 54, we can keep going. I can use 2 again, actually, so 2 can go into 54, 2 can go into 5 2 times with 1 left over, and 2 can go into 14 7 times. And then for 7, I can't do 2 anymore, but I can do that. I know that that's 3 times 9. 3 is a prime number, so I'm going to circle that. And then 9, I can factor into 3 times 3. And so that is going to, both of those are going to be prime. All right, so let's see what we are left with. I've got 3 2's right here, and I've got 3 3's right here. So that means that this is also a perfect cube. So I'm going to pull out those 3 2's as just a single 2 and the 3 3's as a single 3. There are no other prime factors left over, so I just need to simply reduce this, so that equals 6. And we can verify this. We can figure out that 6 times 6 times 6 does equal 216. So that's how we know that that is our final answer. And I'm going to circle these answers as we go. Let's try some cube roots that aren't perfect cubes. Okay, so let's start with 675. We're going to start off the same way. We're going to just use that factor tree to factor this out. I know that 5 can go into this number evenly because it ends with 5. By the way, your divisibility rules are really going to help you with this skill. If you don't know what I mean, I am going to link, I'll put a link right here with my video about divisibility rules. This video will help you know which numbers that these bigger numbers can be divided by evenly. All right, so I know that 5 can go into this evenly because it ends in 5. So let's see, 5 can go into 6 one time with 1 left over. 5 can go into 17 3 times with 2 left over, and 5 can go into 25 5 times. All right, so 5 is a prime number. I'm going to circle that one there. 135 I know can be divided by 5 again because it ends in 5, so I know that that will go in evenly. So 5 can go into 13 2 times with 3 left over, and then 5 can go into 35 7 times. All right, so I can't do 5 anymore, but I do know that 27 is 3 times 9. 3 is a prime number, and then 9 is 3 times 3. Both of those are prime numbers. So you can see how I've used my factor tree to factor down to all of the prime factors, and now what I'm looking for, because we're looking for a cube root, I'm looking for 3 of any of these numbers. So I do have 3 3s, but I don't have 3 5s. If I had another 5 in here, then that would work, but because I don't, I cannot pull 5 out of this root. So what we wind up with is a 3 on the outside, and then 5 times 5 stay inside. So we're just going to simplify. So this 3 square roots of 25, sorry, not square root, cube root of 25. And then that is our final answer for that one. All right, let's go on to number 4. Again, this is not going to be a perfect cubes, but let's see what we can break out of this. All right, we've got an even number, so I know 2 can go into this evenly, so let's see what that gives us. 2 can go into 15 7 times with 1 left over. 2 can go into 11 5 times with 1 left over. And then 2 can go into 12 6 times. Okay, let's break this down a little bit more. Again, I know I can divide by 2 because it is an even number. So 2 can go into 7 3 times with 1 left over. 2 can go into 15 7 times with 1 left over. And 2 can go into 16 8 times. All right, I can break this down with 2 again because it is an even number. So 2 can go into 3 once with 1 left over. 2 can go into 17 8 times with 1 left over, and 2 can go into 18 9 times. All right, so I can't use 2 anymore because this is no longer an even number, but I can divide by 3, and the reason that I know that quickly is because 1 plus 8 plus 9 gives me 18, and 18 is divisible by 3, which means 189 is divisible by 3. So I can divide this number by 3. All right, and 3 is a prime number, so I'm going to go ahead and circle that. 3 can go into 18 6 times. 3 can go into 9 3 times. All right, so I can keep going with 63. 63 can be divided by 3 again. 3 can go into 6 2 times, and then into 3 1 time. And then 21 is 3 times 7, and both of those are prime. All right, so that was a lot of prime factors, but we got them all. So now let's see how many we have of each one. Well, I've got 3 2s, I've got 3 3s, and then a single 7. So that means that my simplified answer is going to be 2 times 3, right? So this 2 is represented here, this 3 is represented here, and then in the cube root is going to be a 7 left over, okay? Then we just need to simplify that, so that's 6 cube roots of 7. And that is our final answer. Let's take a look at some problems that aren't cubes, but they are fourths and fifths. We've got one that is a fourth root and one that is a fifth root. And that is the way that you say these after you get beyond square root and cube root. Just like you would with exponents, you would say x squared or x cubed. And then when you get to those higher exponents, you would say x to the fourth, x to the fifth. Same thing here, you would say fourth root, fifth root, sixth root, and on. But our process is still the same. We're still going to go ahead and break these down with our factor tree, find all of their factors, but this time we are looking for 4 of that factor instead of 3, just like we were in the last problems. So let's break down 128. I know I can divide this by 2 evenly, so 2 can go into 12 6 times, 2 can go into 8 4 times. 64 I know is 8 times 8. Now, if this were a square root problem, I could stop here and this would be 8 square roots of 2. But we're not looking for square, we're looking for 4. So I need to keep going with this. 8 we can split up into 2 and 4. That 2 is a prime number. And then 4 we can split up into 2 and 2. All right, so I've got all my prime numbers there, but then with this 8 we need to keep going. 2 and 4. and then this 4 can be split up into 2 and 2. So all 2's for our prime factorization here. Let's see how many groups of 4 I have. So I see 4 2's right here, and then here I've almost got 4, but there are only 3. So that means that our simplified answer is 2 on the outside, and then these 3 2's have to stay inside the radical, and we're just going to simplify that to 4th roots of 8. And that is our simplified answer. Okay, and our last problem, we are looking at 5th root. So just like in the problems before, this number right here tells us how many of those prime factors we need in order to be able to pull it outside of the radical. Let's start factoring. For 800, I'm going to go with 8 times 100. You might want to split this up into 2 times 400, or however, 4 times 200, however you want to split it up. That's why I like the factor trees, because you can start off with any factors as long as you keep breaking it down until you get to prime numbers. Let's continue with 8. For 8 is 2 times 4. That 2 is a prime number, so I'm going to stop there. But then with 4, I can keep going with 2 times 2. And then for 100, I'm going to break that up into 10 times 10. And then I'm going to keep going with 10. This is 2 times 5. Both of those are prime. And then this 10 is 2 times 5. Both of those are prime. All right, so I've got everything broken down to their prime factors. Remember, I am looking for 5 of a number because this is a 5th root. So I've got 1, 2, 3, 4, 5. I've got 5 2's. So I'm going to go ahead and bring that 2 outside of my radical. And then what is left over? 2 5's. So those both have to stay inside because I don't have 5 of them. I only have 2 of them. So then let's just simplify this to 5th roots of 25. And that's our simplified answer. This is part of my pre-algebra series. I have a ton of videos going over a ton of different pre-algebra skills, so check out the link for those videos in the description below. Please like and subscribe. That really does help me to continue making these videos for you. And let me know what you think about cube roots in the comments, and I'll see you next time.